We're going to start now dealing with more complicated formulas, those involving a metal cation and a polyatomic anion. These kind of compounds are called ternary ionic compounds, containing 3 or more different elements. You still have the metal cation, such as potassium, but now you have a polyatomic ion, meaning many-atomed ion. The polyatomic ion will contain 2 or more nonmetal elements. They will be groups of nonmetal elements that carry a charge. The sulfate ion, SO4 2-, has a sulfate in the center, you can see the structure, and 4 oxygen atoms bonded to it. So the sulfate will travel as a unit, will not break apart. The nitrite ion and the chlorate ion. So just giving you an idea that these ions are units that travel together and carry that one net charge. You will have access to a polyatomic ion sheet that you will use for a while before you memorize the ions. But there are patterns to the naming of the ions. All of your binary anions ended in IDE, but your polyatomic anions will end in either ate or ite. The ate form of the ion will be the one with more oxygens, and the ite form will be the ion with fewer oxygens. You can see the example below, nitrate and nitrite ion. The charges of the ate and ite ions will remain the same. There is a series of ions in the chlorate series where you might have more than just one different oxygen number. So the chlorate ion, ClO3 -1, the chlorite ion would have 1 fewer oxygen atoms with the same charge, -1. The hypochlorite ion would have 1 fewer oxygen than the ite form, and the per-ate form has 1 more oxygen than the chlorate or ate form. So all of the ions in the series have the same charge, just different numbers of oxygen atoms within the ion. Carbonate and bicarbonate are related by adding 1 hydrogen atom carrying a +1 charge to the carbonate ion, reducing the charge from a -2 to a -1. Bicarbonate can also be called hydrogen carbonate ion. You can see the same pattern follows with the phosphate and biphosphate ions, and then occasionally you have something called the dihydrogen ion. Dihydrogen adds 2 hydrogens to the original ion, reducing the charge by 2. Some of your polyatomic ions will end in IDE, but you won't confuse those with the binary ions once you have some practice. So cyanide, hydroxide, and the peroxide ion are polyatomic ions that do end in IDE. The ammonium ion is the only positively charged polyatomic ion. It's the only polyatomic cation. So like any cation, it will be written at the beginning of the formula. To name a ternary compound, it's quite simple. You name the metal cation or the ammonium ion if it is written first, and then you name the polyatomic anion. K+1, NO3 -1, equal and opposite charges would give you the formula KNO3 or potassium nitrate. The calcium ion with a +2 charge and the phosphate ion with a 3- charge. Again, when you bring that 2 down, you will need to put it outside of parentheses. Anytime you bring a subscript down on a polyatomic ion, you will need to put it outside of parentheses. This is telling you that the formula contains 3 calcium ions and 2 phosphate ions. The formula is red, Ca3 parentheses PO4 2. Ammonium sulfate. Again, looking at the charges, you can see to balance the charge, you'll need to bring that 2 down around the ammonium ion, and you'll need to put parentheses around the ammonium ion. Sodium bicarbonate, equal and opposite charges, require no subscripts to be brought down. The 3 remains in the bicarbonate ion. Aluminum chromate, potassium carbonate. The 2 coming down from the carbonate ion does not need to be placed in parentheses. We never put parentheses around monoatomic ions, only polyatomic ions. Magnesium hydroxide. It is very common for students to bring the 2 down from the magnesium charge, but forget to put parentheses around the hydroxide. Every polyatomic ion that you're going to put a subscript on needs to be enclosed in parentheses. You will write formulas with transition metal ions as well as polyatomic ions. So copper 2 sulfate, give the copper a +2 charge. Your polyatomic ion sheet tells you the sulfate ion's formula and charge, and since the charges are equal and opposite, the formula becomes CuSO4. Aluminum phosphate, also equal and opposite charges. So writing your polyatomic ion formulas will take some practice, learning the ions, but you will use your ion sheet until you have mastered the polyatomic ion formulas and charges.